In this video, we're going to look at glycosaminoglycans. And what glycosaminoglycans are, they're sugars that are found in the extracellular spaces of your cells. They're usually found in your connective tissue, and they can be interlaced with collagen and other proteins. And they are unbranched polysaccharides that have a uronic acid. So uronic acid has this COO minus here, and it then has an amine, hexoamine. Here we can see our hexoamine here. A lot of them also have these sulfur groups, as you can see. Now, since you have these negative charges, what happens is that water is highly attracted to these sugars. And so you'll get this slimy, mucus-like substance from these sugars, very viscous and elastic. And one type of glucosaminoglycan we're going to look at is hyaluronate. This is part of your connective tissue, your synovial fluid, and vitreous humor, so the thing that makes up your eye. It's composed of 80 to 8,000 beta-1,4 disaccharide units, shown here. And since it is a negative charge, these negative charges will force the sugar to be extended. So if this sugar was to try to coil up on itself, these negative charges would repel it. Since it's extended and has these negative charges in OHs, it will bind water and cations very readily, and it will become a hydrated compound, and it will have roughly 1,000 times more volume than your dry compounds. And so you'll find these in your joints. Since they're very hydrated, they're very good shock absorbers. Because imagine you have two layers of hyaluronate here. So when you push down on your knee, for example, these negative charges will repel each other, which repels the force of you walking or jumping. So that is why it is your shock absorber. And interestingly enough, hyaluronate is thought to interfere with tumor formation. So there's a species out there in Africa called the naked mole rat, and nobody has ever found cancer in the naked mole rat. They live about 10 to 15 times longer than they should based on their size. Normal mice live like 3 years. The naked mole rat lives up to 30 years. And the reason why, or the hypothesis, is that they produce very heavy hyaluronidates. They seem to be the only organism that does it, and they are the only organism we've really found that doesn't get cancer. So there's some kind of link between hyaluronate and cancer that we quite haven't figured out yet. Now let's move on to pectins, which are alpha-1,4 galactourionates that have ramenose randomly spread in there. So plants don't make these aminoglycans. Rather, they use pectin as their shock absorber, and it will also be a component of their cell wall. These are heterogeneous polysaccharides, and so you have alpha-1,4 linked galactouronate with these ramenose molecules interspersed. And it's kind of like the same idea here. You will have a hydrated gel. These will attract water, making this gel. That will be a shock absorber. We use it to make jams and jellies. We'll throw pectins in there to give it more of that jelly-like or jello-like consistency. And lastly, what we're going to talk about are bacteria and biofilms. So biofilms are an extracellular material that are made out of hydrated polysaccharides like we've been talking about. Since these biofilms are usually made out of different bacteria, the components will be vastly different. And so the polysaccharides on the outside will vary over time, and it will vary where you look at the film. So you can't really characterize these biofilms too easily. And one type of biofilm you should be familiar with is plaque on your teeth. So bacteria in your teeth will make this biofilm. That will prevent them from being dehydrated. It will prevent them from being washed away. And if you have bacteria in your teeth, you will eventually get cavities. And this is a big problem in the medical field. So bacteria growing this biofilm, well, any soluble antimicrobial agent cannot go through this biofilm. So you can't kill the bacteria underneath it. And this is actually a big problem. How to get rid of these biofilms. And they're hard to get rid of because they're difficult to characterize. They're different based on what bacteria you have, and you're different in where you look at the biofilm. So a lot of money is being spent on trying to nullify these biofilms, so we can easily kill the bacteria that are under there. And that's it for this video. I will see you in the next one.